Alright, question 40. I put it into the calculator first, and it tells me that the minimum value is a 35. So 35 is our low number at 35. Our Q1 is at 48. Now again, where did I get these numbers from? I typed in all of this data and then using my calculator. The median was at 52.5, and then quartile 3 is at 63. So let's put in 63, and then the high is 67 right here. So first of all, there's no outliers in this. If you remember, if we take the interquartile, which is this length here from 48 to 63, and we multiply it 1.5 times, so if you took that length and did it another 1.5 times, and if you did that another 1.5 times, we definitely are not in the outlier range. Everything is good to go. So the question is, are there any outliers? Our answer is no. Now again, the way you test that is there's a formula. It's Q1 minus 1.5 times your IQR, and Q3 plus 1.5 times your IQR. And the IQR, the interquartile range, is the difference between, which in this case would be 63 to 48. That value is your IQR. So anyways, the answer is no to this. We created our box and whisker. And our best result would be a mean. And the reason it's a mean is there are no outliers, right? No outliers. And so the mean is always the best. Alright, which grade has the smallest interquartile range? Well, I think that's pretty obvious right there, isn't it? So our answer is the 11th grade. Interquartile range is the width of the box, basically. Which grade has the smallest range? Well, that's also pretty easy. Looks like smallest range right here is the 9th grade. So the 9th grade has the smallest range. Which is least symmetrical? Well, let's highlight symmetricals. This is quite symmetrical, and so is the one I've already highlighted. Least. I actually think the least symmetrical is this guy here. There's quite a, the box is fairly symmetrical, the IQR, but then there's quite a tail here. I would probably vote on less symmetrical as the 11th grade. And who has the worst attendance? I also think that's 11th grade. Let me show you why. See if I can take some of this stuff back here and show you why I think so. Here's why I think it is the worst. Is at this point right here, going this way, 75%, right? Because there's the interquartile range, the two items there and there. So there's 75% of their students are getting 6 or more absences. So I think they're the worst. So this is just reading box and whiskers. Alright, this is just a knowledge of the normal distribution. We learned that in this region here, 68% are gathered. So if the mean is at 78 and our standard deviation is 6, so that would be 84, 90, 96 going that way. This would be 72, 66, and 60. So from here to here, from 72 to 84, you'd get that 66% of the group. The next group would be, if you want 95, you got to get out to the plus and minus 2 deviations. So now we're doing this region here, and we get a value that is at 95 when we get out to this level, 95%. So that would be a range of 66 to 90. And if you want to get all the way out to the third level, third deviation, then this whole region here has to be taken care of. And we get, in that case, the old 99.7. So that would be from 60 to 96. So this is plus and minus 3 deviations. This is plus and minus 2 standard deviations. This is plus or minus 1 standard deviation. Alright, let's look at this one. This is a normally distributed relationship. It says that the mean is at 80 and our standard deviation is 5. So 85 and then 90 and so on. It mentions that we would like to test out 87 and less. So we want to know what's that percentage. Now notice that 87 was not one like right on the nose, right on the 85. So it's not one standard deviation, it's one and a little bit. So we have to use our little z formula. And it looks like this. And all it says is take your number, subtract how far away you are from your mean, and divide by your standard deviation. And we get 7 divided by 5, which is 1.4. Now, that makes sense, right? If 1 is here at 85, 87, and so now we're going to ask our calculator to do this calculation. And so in our calculator we use normal, CDF, and we go from our lowest, which I always use -10, to our highest, which is our 1.4, our median of 0, our 1 standard deviation. And when you calculate this, we get 0.911, in other words 91.92%. That is the amount of people that were under that student score. So again, we have a normal distribution. Tells us that the mean is 64 with a standard deviation of 4. So 60 would be here, 56, 52, going this way would be 68, and another 4 would be 72, and so on. And now what it says is that Jana's height is 54, so Jana's height is right in here. Now that would be -1, -2, it's probably, if I'm just guessing, minus, I don't know, 2.2 or something. But let's calculate that z-score. So that z-score is her score, how far she is from the mean, divided by the standard deviation. So 54 minus 64 divided by 4, which is 10 divided by 4, 2.5. That would be her, minus 2.5, careful. There, minus 2.5, right, because she went this way. Minus 2.5 is her z-score. Last question here in the review. It says, what is the actual score on the IQ that she got? Here's the mean, here's the standard deviation, and here's the z-score. So the z-score again looks like this. So this time it's a little bit different because we're going to attempt to solve for this here. So we plug in everything else and just solve it like an equation. Her z-score was 2.8. We don't know what she had here, but her mean's 100. And then it divides by the standard deviation. Now if we multiply both sides by 10, we get 28 here equals x minus 100. And then when we move the 100 over, we get 128. Her score was 128. Let's see if that makes sense here. Normal distribution, 100. 10 would be 110. 120 would be 2, and she was 2.8, so almost 130. So that's close. That's right on the number.